Today we are looking into sets, and then we are talking about the set theory. Set theory. Welcome to my class. I'm Mr. Bam. Welcome. So let's begin this set theory by looking at the definition of set. What is set? Set. A set is a collection. Set is a collection of well-defined objects. Well-defined objects. You collect them together. So that collection of those objects is called set. You understand? For an example, if I say a set of numbers, between 9 and 16. A set of, let me say, whole number. A set of whole number between 9 and 16. But what are numbers between 9 and 16? That means we are not starting with 9, we take 10. So 10, 11, 12, 13, 14, 15. You don't take 16 because the numbers between. That's the so from 10 to 15. So just say, okay, we have 10, we have 11, we have 12, we have 13, we have 14, and we have 15. But we don't write sets this way. Understand? All these numbers here, we must put them inside what we call a curly bracket. Curly bracket. A curly bracket. C-U-R-L-Y. A curly bracket. So that's how you put your elements. All these numbers here are called elements of the set. The elements of the set. The element of the set, they are the members of that set. So we have 10, 11, 12, 13, 14, 15. Each of them, you understand, as is the element of the set. So now, I can call this whole set, let's say letter A or B or C, any letter you like. So let me use letter A. I can say let this set to be letter A equals to this. This is how you represent set. You understand me now? So that's the set. You understand? Note it. Okay, let me think of another example again. Let's say you are asked to write the set. Let's say you are asked to write a set of let's say a set of even numbers, even numbers, a set of even numbers greater than 20 but less than let's say less than 30. Okay, a set of even numbers greater than 20 but less than 30. What are those numbers? So we're going to start with 20. No, we start with 22 because you don't count 20. The numbers must be greater than 20. So the next even number after 20 is 22, 24, 26, 28. You don't count 30. What are even numbers? Numbers that end with 0, 2, 4, 6, and 8. That's even number. So you have to write what? So let me call the set to be set X. You can use any letter. So let me say set X is equals to, okay, your curly bracket, you open it. So 20, no, you start with the next even number 22. You understand? 24, 26, 28. You don't write 30. So this is a set of numbers. Note it. You understand? So that's the introduction to set. Note it. You have to know that once you're writing your set, you must put the set inside a curly bracket. A curly bracket. And again, the set must have a letter, uppercase. It can be any letter you like. Understand? So this is a set. So note it. Okay. Since I've known that, let's go to the next one. That's what we call the elements of a set. Elements of a set. Okay. What are the elements of a set? Let me tell you this. The elements of a set. Elements of a set. Okay, let me write it. The elements of a set. The elements of a set. Okay. Now, the elements of a set are just the members of that set. The elements of a set are the members of that set. Note it. Understood. So let's say we have a set A equals to, let's say we have 4, 5, 6, and 7. Okay. Of course, we can see, obviously, we know that 4 is an element of set A. 5 is an element of set A. Each of them here is an element of set A because all of them belong to the set A. You understand me now? So it means that 4 is an element of set A, means that 4 is a member of that set A. And a symbol for elements. 4, listen to me, 4 is an element of set A. You don't write it this way, you have to write it symbolically. The symbol of element is this, just like E, like this. This is my symbol of element. So I'll just say, okay, 4 is an element, you can see, of set A. You can see. Okay, then what about 5? Can we say 5 is an element of set A? Yes. 5 also is an element of set A. That is, 5 belongs to A. You understand me now? So note that. Okay, can we say 10 is an element of set A? No, because 10 cannot be found in this set A. So how do you write that? You just say, okay, 10, look at it. This is element. But mean not, just put not. Okay, it's not an element of set A. Understood? So that is that about the element of a set. Very easy and simple. Note that. Okay, having known that, let's go to set cardinality. Set cardinality. The cardinality of a set. The cardinality of a set. Okay. Now, the cardinality of a set, is the number of elements in that set. The number of elements in that set is called what? The cardinality of that set. Very simple and easy. Just count the number of elements you can find in that set. It is called cardinality. Let's say we have set Y equals to, let's say we have A, B, C, D, and E. And you have to find the cardinality of this set Y. Just count it. 1, 2, 3, 4, 5. That's 5. But you have to write it like this. Say the number of elements, n is number, in that set Y is what? Is 5. 1, 2, 3, 4, 5. So that is the cardinality of the set. Don't forget, if you are watching my video for the first time, kindly hit the subscribe button so you can get more and more of my video, Mr. Bam. So that's the cardinality of that set. You can see it's very simple, but you have to take note. What the letter we are going to put here should be that set itself. The set should be here. Number, if we have A here, you have to put A. You have B here, you have to put B. You understand me now? That's cardinality of the set. So note that. Though I'm still coming to set builder's form, set builder, whereby I will explain it more better. But we are still taking the introduction, you understand me now, to set. Okay, having known that, let's quickly go to some types of sets. Some types of sets, you understand me now? You can just take your pen and put it down. For this class, just kindly sit down, relax yourself, and listen. You can take your pen and write 1 or 2 things. Okay, let's go to some types of sets. Some types of sets. Types of sets. Okay, some types of sets that we have. Understand me now? Okay, we have different types of sets. We have the universal set. Universal set. You understand me now? When you say universal set, from the word universe, universal. Universal set, universal set, universal set. You understand me now? So the universal set is very simple and easy. From the word universe, you understand me now? Think of it like a mother that gives birth to 3 children. You understand me now? So that mother is the universal set. So you can say the universal set is a set from which all other sets are taken from or are observed from. You understand me now? That's the universal set. And it has a symbol. Look at the symbol of universal set. Actually, every subtopic in set, anything we talk about will have its own symbol. That's one thing about set. So this is the universal set. You can do something like this. Write your U very boldly and drop this one down like this. Just drop it down like this. Call it mu. So this is your universal set. Or some can write it this way. Write your E like this. Your E, and then bring something like this. Something like this. You can see. So either of these two can be your what? Your universal set. Hope you understand it. So that's what we call universal set. So note it. Understood. So we are still coming there by the time I take other types of set that we have. Note it. Okay. Don't forget to drop a positive comment and like this video. You understand? Okay, having known that, we also have what we call let me call this one number one. Understand? Let me call it number one. So we also have this. We have different type of sets. We have the null set, the null or empty set, the null or the empty set. Because even obviously from the name, when you say empty, that's a set that doesn't have any elements. So an empty set or a null set is a set that has no elements. No element. Understand? That we call a null set or an empty set. Let me call this set to be set B. I'll say set B. This is symbol of null set or empty set. Just do it as if you want to your curly bracket, but there is no element, no number there. So that is an empty set. You can see now. Or you can write something like this, like the form of 0 and cancel like this. So this is empty set or null set. Any of them can work for it. But some normally write this. They write both empty and null. This is wrong. You don't express your empty set and null set this way. You can either express it this way or this way. Note it. Understood? Okay, that's an empty set or a null set. Like if let me ask you, let me give you an example of an empty set. If I say a set of, let me give you an example of empty set or null set. If I say a set of even numbers between 20 and 22. Look at this set. A set of even numbers between 20 and 22. Of course, we know that the next even number after 20 is 22. So there is no set in between. So how we answer, you can say, okay, let the set be set X. And also the set X equals to, there is no element. So this is an empty set or a null set. You can see, note that. So that's for null set or empty set. Okay, let's look at other type of sets. There's a set we call the singleton set. Singleton, the singleton set. Singleton set. Obviously from the name, single means one. That is a set that has only one element. So a singleton set is a set that has only one element. Note it. Let me give you an example. Let's say we have set B equal to, let me open my curly bracket. Just put only one element, maybe Y. Only one element. Think of it like a mother that has only a child, just a child. So that's a singleton set. That's what we call a singleton set. Hope you get that. Okay. So let's take another one again. Let's take let me see. Yes, finite sets. The finite set. We have the finite set and the infinite set. If you look at finite, we must also look at infinite. The finite set and the infinite set. The infinite set and the finite. So let's say the infinite set. What's the finite set? From the word finite. From noun, finite noun. So it's a set that has a countable number of elements. You can count the number of elements, not infinity. You understand that? Okay, let me give you an example. If we say a set of numbers, a set of whole numbers from 1 to 100, just count 1, 2, 3, 4, 5, 6, up to 100. Numbers from 1 to 100, they are countable. You can count. But if I say a set of integers, we cannot, integers can be positive integers or negative. Positive are +1, +2, +3, +4, +5, +6, +7, +8, up to plus infinity. Infinity means a number we cannot reach. That is uncountable. Then also negative integer, negative, -1, -2, -3, -4, -5, up to minus infinity. So that is an infinite set because it contains an uncountable number of elements. But a finite set contains a countable number of elements. If you are given any set that you can count the actual, element without being exhausted. This one I can't count again. So that's what we call a finite set. Hope you get that. Okay, so that's that for the type of set that we have. If we have other ones, I will remember and I will tell you before I end the class. I promise you that. Okay, having known that, let's go to some operations in set. Some operations in set. Okay, some operations in set. Some operations in sets. Okay, operations in set, operations in set. So set operations, set operations, set operations. Okay, so we're going to look at subsets and supersets. That's what we call subsets and supersets. Subset and superset. Some can put these two sets under types of sets. You understand me now? It can also be formed under, taking under types of sets or operations in set. Understand? So now the word sub means the smaller part. Super means the higher part. Understand what I mean now? So subset is like maybe we have two siblings, the younger one and the older one. So sub is the younger one, while super is the older one. Note it. Now let me give you the definition of a subset. Like I told you before, every part of set has a particular symbol. The symbol for any part of set. Note it. Okay. Now, let's say we have set A. Listen, I want to define subset now. A set A is the subset of set B. You can write it down. Set A is the subset of set B if A and B contains elements. Both A and B contains elements, whereby B contains at least one element that is not in A. B contains more elements, that is, B contains at least one element that is not in A. You don't get set A and set B, they both contain elements. Understand now? So all the elements in set A has been exhausted. Now for set B, all the elements in set A are already present in set B, but B still have more elements that is not present in A. You get the point now? That's what we call subset. So A is a subset of B if both A and B contains elements, whereby set B contains some elements or at least one element not present in set A. That we call subset. And if A is a subset of B, then B is a superset of A. It's like opposite. Notice now. So let me give you the symbol of the two. A is a subset, the symbol of subset of B. A is a subset of B. Notice. Just like, think of it like as a less than in math. We have less than, greater than. By saying A is less than B. So the same way. So if A is a subset of B, then B, can you think of superset? It will go back. It's a superset of A. That is, B is greater than A. I'm just using this for you to understand it. Understand me now? So this is subset, while this is what? Superset. Note it. Understood. Now let's take one or two examples to break it down. It's very easy and simple. Let's say we have set A to be, let's say, excuse me please. Let's say we have set A to be, let's say we have A, B, C, D. And let's say we have set B as, let's say A, B, C, D, E, F. What can you see here? A, B, C, D is here and it's also here. But all the elements in A has been exhausted. B contains all the elements in A also. But B still have more, elements that are not present in A. Therefore, A is a smaller one, B is a higher one. So A is a smaller part, subset of B, while B is a superset of A. Hope you get the idea. That is subset and superset. Hope you get it. Thank you. Okay. Having known that, let's look at set difference. Yes, set difference. Set difference. Set difference. Let's look at what? Set difference. Okay? Set difference. Set difference. Okay? Now, if I have A minus B, of course, difference means, there will be a, negative, like subtraction sign. A minus B is very simple. It means A minus B is a set, you can put it down, is a set containing the elements present in A but not present in B. Element that you can see in A, this minus means not, you take away B, not in B. So if you are given two sets, let's say we are given two sets, A and B, you understand me now? So A and B, they both have their own elements in their curly brackets, you understand me now? And you are asked to find A minus B. It means the set that you can see in A but cannot be seen in B. Just check those two sets, you understand me now? That's A minus B. The same thing goes for B minus A. It means the element you can see in B but not in A, because minus A means not in A. Let me give you an example. Let's say we have set A as 4, 5, 8, 9, and let's say we have set B as, let's say we have 5, 6, 10, 11. Now, let's say you are asked to find A minus B. Find set A minus B and find set B minus A. What's that going to be? What's A minus B? Just check. A minus B means what you can see in A. What you can see in A here, but you cannot see in B. Check it yourself. What can you see in A, but cannot see in B? Let's check. 4 is in A, but 4 is not here. So 4 is there. 4. 5, no, is there. 8 is in A, but 8 is not here. So 8. What again? 9 is in A, but 9 is not here. 4, 8, 9. So this is my set A minus B. Can you pause the video and try B minus A by yourself? Try it. So let me do it now. That's what you can see in B, but cannot see in A. What can you see in B, but it's not in A? 6 is in B, but it's not in A. So 6. Okay. 10 is in A. 10 is in B, but it's not in A. 10. What again? 11 is in A, but 11 is in B, but it's not in A. 11. I could have taken 5, but 5 is in 2. You understand me now? So that is what we call set difference. Hope you are enjoying this class. Don't forget, subscribe to my YouTube channel, share my videos, let others also watch it, so we can all learn together. Understand? Okay? Having no set difference, let's go to union, intersection, and complement. Union, intersection, and complement. Mind you, this is set operation 1. We still have more. So I will still do more. You understand me now? More for you. So let's see. Let's look at union. Union. The union of two sets. The union of two sets. The union. And let's look at the intersection. The intersection. The intersection of two sets. Okay. And let's look at the complement. The complement of the set. The complement of a set. All these also, they have their own symbols. They have their own symbols. You understand me now? Union of two sets, intersection of two sets, and the complement of a set. Mind you, this video I'm doing, it's cut across anywhere you are in the world. You may be in United States, you can be in United Kingdom, you can be in Australia, you can be in Canada, you can be in Africa, you can anywhere you are. These sets are still the same. I'm trying to give you a general video. You understand me now? So you can watch from anywhere. You can share my video to anybody in any part of the world. You understand me now? Okay. Now let's look at the union of two sets. In fact, any level. If you are in grade 10, grade 11, grade 12, year 10, year 11, year 12. In Africa, if you are in SS1, SS2, SS3, you can. In fact, if you are in colleges, we have set theory also in colleges, also even in university, the first year, we have this set also. So you can enjoy this. You can share the video to anybody you know in that level, or you can be a teacher that you want to learn one or two things here. You can also learn it. You understand? Okay. Now let's look at the union of two sets. Think of union as, marriage is a union between a man and a woman. So think of, we have two sets. Two sets. Let's say we have set A and set B. You understand now? Set A has its own elements, set B has its own elements. Think of union as bringing the two elements together. You understand now? And each of those elements will appear once. Let's say set A has 2. Set B also has 2. Don't say 2, 2. No. You write out 2 once. You understand what I mean now? So just bring all the elements in set A and set B together and write each of them once. Each of the elements will appear once. You understand what I mean now? That's what we call union. Now, intersection. Think of intersection as the common, from the word when you say intersect. The common element that you can see in A and also in B. You write it out once. Each number must appear once. That is what we call intersection. And complement, from the word complement. The word when you say complement means complete. You complete it. Now, let me explain to you. I've explained the universal set, like the set of all the sets, where all other sets are taken from. Now, let's say we have a set, which is the mother. And the mother has two children. Now, let's say we only have a child. Between those two children, we can only see the first child. Where is the second child? The second child is the complement that completes the first child, so there can be two. You understand what I mean? The two children of that mother. You understand what I mean? So the complement of a set A, I'm trying to define it for you now, is a set not present in that set A. You understand now? So when you say complement of anything, that means that thing, you will not take the elements there at all. That means outside of that set that you are talking about. That means the complement of a set A is a set that is elements not present in that set A, but present in the universal set, the mother. That's what I mean now. That's what we call the complement of a set. I will give you some examples here. Now, let me also define union and intersection. You can take your pen and put it down. The union of two sets A and B is the set containing elements present in either A or B or both of them. Either A or B or both A and B. That's what we call union. Don't forget, it's a set containing elements present in either A or B or both A and B. That's union. While for intersection, is a set containing elements present in both. When we say intersect, both A and B. Now, while the complement of a set A, I've told you before, is a set containing elements not in that set A, but in the universal set. So if you are asked to find the complement of any set, that means that set that you are given, you will not touch any element there. You focus on the other element that is in the mother, the universal set that you will have been given in the question. Hope you get that point. Let me give you one or two examples to explain it. Okay. Now, let me let me see. Now, union. Like I told you before, each of these subtopic has its own symbol. The symbol of union is U. U for union. Like U for union, you can see. Now, intersection is like the opposite. Just turn this one upside down. Intersection, you can see. While for complement, it has two symbols. Let's say you are dealing with set A. The complement of set A is just put like a form of raised power C, like C. You know the symbol of radians. Angle can also be in radians. Angle, we are familiar with degrees. So the symbol of radians in angles, that's symbol of complement. Just say C for complement, raised to power C. This is A complement or prime. You can say A, this symbol prime, A prime. That's symbol of either prime or complement. It still means the same thing. Hope you get it. It means the same thing. Note it. Understood? So this is union, this is intersection, this is complement or prime. Don't forget that we have taken symbol of what's this? Can you remind me? This is a subset. This is a superset. This is union, intersection, complement, prime. Note it. What about this one? We have taken a lot. This is a universal set or this universal set. So far, note it. Why this one called? This is a null set or empty set. We have taken some symbols so far. So please master those symbols. Very important in sets. Now let's take one or two examples under union, intersection, and the complement. Okay, so I'll also formulate another example for you now. I will formulate another example for you now so I can look at it. You understand me now? Okay, good. Now let's see. Excuse me. Let's see. Now, let's say we have please an example. Let's say you are given the universal set as, let's say we have 1, 2, 3 up to, let's say up to 10, and we have set A as, let's say we have it as 2, 4, 5, 6. We have set B as, let's say we have 1, 2, 4, 6, 8. And we have to write down the elements. Let's say number 1. Let's say we have A union B. Number 2, we have A intersection B. Number 3, we have A complement, A prime. Number 4, we have B complement. Number 5, we have A intersection B, everything complement. Don't mind you, I can also use that symbol C for my prime or complement. Let's say we have A complement intersection B. Let's say we have to do this one also. Number 7, we have to do A complement union B complement. So let's look at this. Let's look at this. Mind you, if you have any questions so far, don't hesitate to drop it in the comment for me. You understand me now? So I will explain it to you. Let me please permit me to clean this topic. You understand? So let's see. So let me stop here. So in my next class, I will continue from here. Understand me? On that set. Make sure you subscribe so you can get more and more of this video. Now, once again, welcome to Mr. Bam's online class. Hope you have gained 1 or 2 things from my class so far. Don't forget to like my video, comment, and subscribe. Share my video. Thank you.